For this example, we do need to find the 6 trigonometric functions, and the only thing they give us is this ordered pair, this point. So let's get a visual for what this represents. Let me put this on an XY coordinate system. Okay, so we have a point here, point -6, +2. So that would be that point right there, -6, +2. And that's all they give us, but we're supposed to find the 6 trigonometric functions. And this point lies on the terminal side of the angle. So for these problems, here's what we need to know. They're putting this angle in standard position, which means to get one of the sides of our triangle, we want to connect this point back to the origin, back to 0, 0. So that is one of the sides of our triangle. How do we build our right triangle in order to come up with the rest of this? You always start at the point that they give you, and then you draw a vertical line to the x-axis. In this case, our point is up above the x-axis, so when I draw on my vertical line, I'm going to be drawing downward, and then connect that back to the origin again, and that gives us our right triangle. From there, we have to figure out the side lengths, then we can use SOHCAHTOA to find those main 3 trig functions. The side length here is pretty easy for 2 of the sides, because we have this length here on the x-axis, and we know that that has a length of 6, and then we have this vertical piece here, and we know that that has a length of 2. But when you are putting these sides into a coordinate system, we do need to sometimes have positive and sometimes negative sides, depending on direction, not necessarily length. So the length of this side right here, that has a length of 6, but if you start at the origin and go over this direction, we're going over to the left, and that's in a negative direction. So the length of this side right here, we would say actually is -6. Negative because we're going to the left, and 6 because that's how long it is. This piece right here has a height of 2, and we are going from the x-axis upward to the point, and that is in a positive direction. So that side length is a +2. You can use the 2 values that are here to get those 2 side lengths. This horizontal piece that's right here is always going to match the x-coordinate of the ordered pair they gave you, and the height is going to match the y. So we have -6, 2 for our ordered pair here, so I know the horizontal piece is -6, and the vertical piece is going to be a +2. From there, we can use the Pythagorean theorem to figure out the length of this missing side here. This is our hypotenuse, so these 2 sides we have, those are the legs, those are A and B. So using our Pythagorean theorem, I could say -6 squared plus 2 squared is equal to c squared. -6 in parentheses squared is 36, and 2 squared is 4. 36 and 4 is 40. So 40 would be equal to c squared, and if we did the square root on both sides, we would have c is equal to plus or minus the square root of 40. The plus or minus that's there, well, we need to know, is this side length, with the direction that is, do we call that positive or negative? And the rule for this is this: the hypotenuse can never ever be negative when you are putting a triangle into a coordinate system dealing with our trig functions. So the 2 legs, they could be positive or negative. That gives us our direction, but the hypotenuse is always positive. So we're just going to use the positive root there, and we'd want to simplify it as much as we can. The largest perfect square that's a factor of 40 is 4. So c is going to be 2 times the square root of 10. And now that I know the lengths of my three sides, now I can go in and I can use SOHCAHTOA on this to figure out our three main trig functions. The last thing I need to do in order to know that is, where is our angle theta? We do know that theta is one of our acute angles, and the rule for this is that your angle theta is always the one right next to the origin, right next to 0, 0. So theta is that angle right there. So if I go through and label my sides, I do know that we did calculate the hypotenuse earlier. That's 2 root 10. And then with regards to theta, the one that's straight across from it is 2. So this is our opposite side. And then the -6 that's here that touches angle theta, that is the adjacent side. So let's go through and come up with those main three trig functions. Using SOHCAHTOA, I know that the sine of our angle is equal to opposite over hypotenuse, which is 2 over 2 root 10. The regular numbers that are here, I can see that those will reduce. We have a 2 on the top and a 2 on the bottom. If we cancel those out, that would give us a 1 in each one of those positions. So we would have a 1 on the top of the fraction, then a 1 root 10 on the bottom, which would just give us root 10. Well, I simplified that a little bit, but it's not in a very good form. We have a square root in the bottom, so I do want to rationalize that. So if I multiply top and bottom by the square root of 10, we would have square root of 10 over 10, and that is now simplified and in its best form. So there's what sine is equal to. Cosine, that's the ka part of SOHCAHTOA, that would be adjacent over hypotenuse. And like we just did with sine, we'd want to reduce these. -6 over 2 would give me a -3 over 1. So we'd have a -3 on the top and then a 1 root 10 on the bottom, or just root 10. I can't leave that square root of 10 on the bottom though. I need to rationalize. So that gives me a -3 square root of 10 over 10. I want to check and see one more time if I could reduce these regular numbers, but 3/10 does not reduce, so that's our final answer for cosine. And for tangent, tangent is opposite over adjacent, so the tangent of our angle would be 2 over -6 or a -1/3. From there, we have three more trig functions to do, but they are the reciprocals of these three. So let me go through and calculate those three reciprocal functions. The reciprocal of sine is cosecant. So I want to do the cosecant, CSC. I want to do the cosecant of our sine angle. You always can take your final answer and flip that over and then simplify. But remember, if you show your work when you're doing these first three, there are actually a lot of times a couple of different values that we could flip over. These three green fractions we have are all the exact same number. If you typed each one of these into your calculator, they would all be the exact same decimal. And I can flip my final answer over here, but I could also flip 1 over root 10 over, or even 2 over 2 root 10 over. I could flip any one of these three over to get cosecant. If I take square root of 10 over 10 and flip that over, that's going to put a square root on the bottom, which means I'll need to rationalize, which isn't a big deal. I can go through and do that and come up with the correct answer. But if I choose this version of our final answer, 1 over square root of 10, and I flip that over, that's going to put the square root of 10 up at the top. So we end up with a square root of 10 over 1, or just square root of 10 for our final answer in that one. And that is a much better option. That's a lot less work than to go through and simplify. You get the same answer either way. The cosecant is going to be equal to a square root of 10. But if you choose which of these values you're going to do the reciprocal of, you can make that happen in a little bit easier format. The reciprocal of cosine is secant. So let me take a look there. And again, I could take my final answer and flip it over, not a problem. But I do have another fraction here that it's equivalent to, and that square root's on the bottom there. I hadn't rationalized it yet, which will help me when I get to this step. So I'm going to take a negative 3 over root 10, and I'm going to flip that over. That's going to give me negative root 10 over 3, and that's already simplified, so I don't have to do any work there. If you'd taken the final answer, again, you would need to go through and rationalize and simplify that fraction down to this. Same answer either way. I'm just choosing one that is less work. Tangent of angle theta is a negative 1/3. If I flip that over, I get a negative 3 over 1 or negative 3. So for this problem, they gave us a point. From there, I drew in a side back to the origin, and I used those two coordinates to basically come up with the lengths and direction of the two legs. Using the Pythagorean theorem, I came up with the hypotenuse. The two legs, again, they could be positive or negative depending what quadrant you're in. Hypotenuse is always positive. Make sure when you're building this triangle that when you put your point in, you're always drawing a vertical line to the x-axis to build your triangle, and you're labeling your angle theta next to 0, 0. Then from there, it's just a matter of SOHCAHTOA and simplifying and rationalizing to get sine, cosine, and tangent. You can always take your final answer and flip those over to get the three reciprocal trig functions, but sometimes there is an equivalent fraction a little bit earlier in your work that you can flip over, so you don't have to do quite as much work with that.